In this tutorial, we will use a simple task to show how to use IterX. Our goal here is to design a sorting algorithm for a list with an unknown but non-random data distribution. We named the task fast sort. Ask IterX to implement a fast sorting function called mySort. The reward is defined as the inverse of the number of operations, and we use the quicksort algorithm as the initial implementation. We click Next here to create the task and obtain the task ID. We can also directly use the API to create the task, and as we can see, information such as initial code and task description have already been filled in the code. We copy the code, paste it to my local IDE. Let's add a line here to print the task ID. I also need to change to my own API key. And run. As can be seen, a new task is created using API. Let's go back to tasks. As can be seen, the task with the exact ID has been created. We click the task. Although the task has been created, training hasn't started yet. The progress is 0%. This is because we need to set up the reward function on our local machine before the program can proceed. This is actually the core part of reinforcement learning. We need to provide reward for each generated code. We copy the script to our local machine. Again, we need to change the API key. Let's have an overview of this Python file. Inside the while loop, we first call the IterX API to fetch all code IDs. For each code ID, we get the code content in the form of string and evaluate it using our reward function and get the reward. Next, we push the reward back to IterX. This loop repeats until completion. The current reward function is a placeholder, and we need to change it. The reward function takes the generated code as input in the form of a string and returns 4 parameters. The most important parameter is the reward. It is a scalar and represents how well the code performs. A higher reward means better code, and the value must be non-negative. The second parameter is code error message. If the code fails when we run it, we return the execution error here. This helps the model understand what went wrong and generate better code in the next iteration. The third parameter is correctness check, which is a Boolean value indicating whether the output of the code is actually correct. Finally, the fourth parameter is details, where we can include any intermediate results. If you don't need it, you can simply return an empty string. I'll paste the code I prepared earlier here. Recall that our goal is to design a fast sorting algorithm to sort the list. Here is an example of the input code in string form. We first load the list to sort. Since the code is provided as a string, we use the exec function to turn it into executable Python code. Recall that in the task description, we ask the model to set the name of the sorting function to be mySort. If mySort is not in the namespace, the code is invalid. In this case, we set code error message. If the code contains an error, the reward must be 0, and the value of correctness check does not matter. So we simply set it to false. Next, we execute the code on the input list and record the runtime. If the code fails to run, we record the error message, set the reward to 0, and return. We also need to verify that the output is correct by comparing it with the gold output. If it is not correct, we set the reward to 0, set correctness check to false and return. Finally, we set the reward to the inverse of the execution time and return. This concludes the setup of the reward function, and we can run the code. As we can see, the code iteratively fetched the generated code, evaluate it, and push the reward. Let's go back to the task page. As we can see, the training is in progress. Good luck with your task, and see you next time.